Alright, a few things that we're going to talk about here. One is oxidation numbers, the other one is balancing half equations. So oxidation numbers, how to do these is it's basically assigning a theoretical charge to a substance. And the way we do that is there's a few rules that we follow. One, oxygen is always equal to -2. Hydrogen is always equal to +1. This is -2 except for when it's a peroxide, but you hardly ever get peroxides. But if it is a peroxide, what it will be is -1. Okay, so that's the little exception to the rule of oxygen being -2. But take it as -2 for 99% of all problems. Hydrogen is always +1. Except when it is combined with a metal ion, and therefore it will be -1. But just for all intents and purposes, basically for 99%, it will be +1. If you have an element and something on its own, it will have a oxidation number of 0, and the compounds always add up to the charge on that compound. And I'll give you a couple of examples on how this actually works now. So let's have a look at assigning oxidation numbers to the following things. If we have something like, what have we got? Magnesium oxide, MgO. Okay, it's not an element, so it's not going to be 0. So our oxygen here, as we said before, is always -2. We can see it's always -2. So oxygen will be -2. That means overall it has no charge. So therefore, your magnesium and your oxygen must add up to 0. So therefore, the magnesium must be +2. And therefore, you have your oxidation numbers for each of these. If I have something like hydrogen sulfide, H2S, our rule before of hydrogen was always +1, so therefore hydrogen must be +1. Okay, we have 2 hydrogens, so overall we have +2 there. The overall charge on this compound, or this molecule, is 0. So that means your hydrogens and your sulfur must add up to 0. So that must mean if the overall charge on overall oxidation number on hydrogen is +2, because you have 2 of them, sulfur must be -2. And because you have one of them, it must be -2 there. Hopefully that makes sense. Moving on, there must be another couple of things. If I have something just by itself, like H2, which is a gas, this is an element, you only have one of these. So instead of hydrogen being +1, it's going to have an oxidation number of 0. So that's how your elements work. If it's just one symbol by itself, it's 0. If I have something like N2O, now our oxygen is always -2, so we'll put -2 here. Okay, that means overall the charge is 0 here, so that means all your nitrogens must add up to -2. You have 2 nitrogens, so each one must be +1. See how we got +1 times 2 makes +2, and the overall charge adds up to 0. It's just basically a bit of algebra, so it's just playing around with the numbers in your head. If I do carbonate, or hydrogen carbonate might be a better one, HCO3 negative, it's your hydrogen carbonate ion, or your bicarbonate ion. What we want to do is assign oxidation numbers to this. Hydrogen is always +1. Oxygen is always -2. You have 3 oxygens, so the overall charge here is -6. You have 1 hydrogen, so your overall charge is +1. What's your carbon going to be? +1 take 6. Alright? your overall charge here is -1, so you want to make it add up to -1. So what we're going to do is going to go for, how do we get -1 from this? And it has to be +4 here. This one has to be +4 because +4 plus +1 here plus 4 here gives you, take away the 6 gives you negative over here. So there's your oxidation numbers for this. Now from our song, remember, if your oxidation number changes, you have an oxidation or reduction reaction. And if your oxidation number goes up, what happens is you get an oxidation reaction occurring. Okay, that's oxidation numbers. And I'll stop this and I'll make a new podcast, a new YouTube video for balancing half equations.